This is a recording of the first half of the 6.2 section notes that's about transforming and combining random variables. This particular recording is going to be using TI Inspire as the technology to get the job done. In a previous chapter, we learned about linear transformations. We learned about how to if you added or subtracted a constant to every observation in a distribution, that it affects uh, center and location, but does not affect shape or spread. We also talked about the fact that if you multiply everything by a uh, constant b, it affects center and location and spread, but doesn't affect shape. We're going to look at that under the same idea having to do with random variables. And so for this particular lecture, we're going to say, let's look at this just this random variable distribution. Pete's Jeeps Tour offers a popular half-day trip in a tourist area. There must be at least two passengers for the trip to run, and the vehicle can hold up to six passengers. The number of passengers X on a randomly selected trip um, has the following probability distribution: two passengers, 15%, four passengers, 35%, so on and so forth. Let's find the mean and the standard deviation for that distribution X. So to do that, I'm going to switch over to my calculator. I'm going to add a lists and spreadsheets page, and I'm going to say, we'll call this passengers. Nope. Yeah, we'll call this passengers. And again, the different numbers of passengers could be two through six. Okay, great. And then we're going to go to the second column and we'll put in the probability associated with each of these. And it was like 15% for two passengers, 25% for three passengers, 35, 20, and 5%. And if you remember from an earlier section, we can add a page, calculate a page, and we can look at the mean and the standard deviation for this distribution. That's under Menu, Statistics, Stat Calculation, one bar stats. We only have one data list, and it's called passengers. The frequency list is known as probabilities, and we're going to go ahead and take a look at those on this printout. 3.75, that's our mean. Let me go put that into our notes. 3.75 is our mean, and our standard deviation is 1.0897. We're going to round that to 1.09. Okay, so that's all things that we've done before. But now we said, what if we did a little bit of a linear transformation? Pete charges $150 per passenger. Let C be the amount of money that Pete collects on a randomly selected trip, because the amount of money Pete collects is 150 times the number of passengers. We can write C is equal to 150x. Write that again. C, the new random variable, can be found by taking the old random variable and multiplying it by 150. All right. So if we take two passengers multiplied by 150, oh, Pete collects $300. If we have three passengers, we multiply that by 150, we get $450. And so the question then becomes, well, what's the mean and the standard deviation of this particular random variable? Now, to go back to our calculator, I'm going to go back to the sheet where we put in this. And this is, I call it, I guess, sales, how much money in sales. And I think it was like 300, 450, 600, 750, and 900. Yep, those are the numbers. And we just have them in a different list. If I go back to our calculator page, I can say, well, let's go ahead, let's do those calculations again. Let's go statistics, stat calculations, one bar statistics, only one data list. That data list is now called sales. and its frequency list is still probability. And what do we have? Well, we've got new values for the mean and the standard deviation. 562.50 for the average of the sales and 163.46. 163.46. Now, it might jump out to you that maybe if we took 150 and we multiplied it by the old mean, and go and do that, that was indeed 3.75, but multiplied by that multiplier, lo and behold, we end up getting that same 562.50. In other words, maybe we find this new random variable by simply just taking the old mean and multiplying it by the multiplier. Does that hold true here? Is 150 times 1.09 the same value? Well, let's take a look. 150 times 1.09, and we get 163.50. Oh my gosh, 163.50, not exactly the same number, but we did round on that part. So I think we can successfully say, yeah, I think those are the same numbers. And what do we see in terms of the shape? Here's the old shape for passengers. Here's the new shape. They look the same. All right. So what do we think? We think the shape stayed the same. We think the new center can be found by taking the old center and multiplying it by the old mean. Now, maybe more generically, we could say if our transformation is bx, then our new mean is simply the mean times the old mean. And what about the spread? It looks like the spread was 150 times the old spread, the old standard deviation. Or maybe we can say more generically, the new standard deviation is simply b times the old standard deviation. Okay, so in general, multiplying or dividing by a constant changes the center, changes the spread, but does not change the shape. Oh, and by the way, the variance gets bigger by b squared. Well, what else could we do with this? Here's that last random variable that we just calculated, and the mean and the standard deviation of this. But it says here, it costs Pete $100 to buy permits, gas, and a ferry pass for each half-day trip. The amount profit B that Pete makes from this trip is the money collects minus $100. In other words, the profit V is C minus $100. So let's create this new random variable C. Let's take the 300, subtract 100 from it, and get 200. Let's take the 450, subtract 100 from it, and get 350. Creating a new random variable, and let's see what the mean and the standard deviation of that random variable is. So I'll go back here, and I'm going to go back to our list and spreadsheets page. And now, instead of sales, we're going to be looking at profit. And what's the profit? It's each of these numbers minus 100. So 300 minus 100 is 200. This is 350, 500, 650, and 800. All right. And what do we get when we do the analysis this time? Again, menu, 6 for statistics, 1 for stat calc, and 1 for one variable statistics. Only one data list, and this time that is profit. Frequency list is the probabilities that we talked about. And what do we see this time? Well, we see 462.50 as the mean. 462.50 is the mean. Wait, isn't that 562.50 minus 100? Could we say that the new mean is the old mean minus 100? Sure looks that way. What about the standard deviation? Um, the new standard deviation is 163, 163.46. 163.46. How's that compare to the old one? Oh, well, except for the rounding, they're the same. Could we say that the standard deviation, sorry, I put X here, this is really should be C, is just that manipulation. Oh, it's just adding or subtracting $100 had no effect on the standard deviation. What about the shape? Here's the old shape. Here's the new shape. They look the same. So no effect on shape, but the center, the new center, looks like the old center minus 100. Or more generically, if our if our transformation is C minus some constant A, that therefore the new mean is the old mean minus that value. What about the spread? We said the spread stayed the same. So under these circumstances, the spread is just the same. No changes to the spread. If we add or subtract some constant to the terms. All right. So in general, adding makes changes to location and center, but does not change the spread and does not change the shape. If we take both of these in combo, adding and multiplying, okay, shape stays the same. The new mean, and this is where I'm going to say this is important, the new mean is found by simply doing the linear transformation of the old mean. The new standard deviation comes from multiplying the multiplier only. Now, there's an absolute value of B around this only because the spreads can't be negative. So just in case the multiplier is negative, you have to take that negative sign away. Let's see this in action. It says, in a large introductory statistics course, the distribution X for all scores on a test was approximately normally distributed with a mean of 17 and a standard deviation of 3.8. I'm just going to write that up. 7.2, 3.8, normally distributed. It says the professor decides to scale the scores by multiplying raw scores by 4 and adding 10. In other words, y is 4 times x plus 10. And so can you find the new mean? Well, the mean of y will be 4 times the mean of x plus 10, which will be 4 times 17.2 plus 38. Well, let's see what that is. 17.2 times 4 plus 38. Not 38. Adding 10. Adding 10. Didn't think that sounded right. Okay, 78.8 is your new mean. Okay, what about your new standard deviation? Well, 4 times the old standard deviation, and remember, do not put in that plus. So this is 4 times 3.8, and that is 15.2. All right, there's our new distribution. And because the shape stays the same, we could say that y is normally distributed with a mean of 78.8 and a standard deviation of 15.2. So say, what's the probability that a randomly selected student has a score of at least 90? Well, shape stays the same, normally distributed. The mean, 78.8. The standard deviation is 15.2. And if we add those two together, we get one standard deviation above the mean, which is 94, I think. Go one standard deviation down, and you're at 63.6. Again, that's 78.8 minus 15.2. It says, what's the probability that a y value is at least 90? Well, let's switch over to this pen, draw a line where 90 is, at least 90. That would be the amount in that tail. How do we calculate that? Well, based on our earlier work, we can go to the calculator, menu, probability, and we want it distributions 5, and we're going to use the normal CDF. Our lower bound is 90. Our upper bound is infinity. Find the infinity under the pi button. Our mean is 78.8, and our standard deviation is 15.2. And we get 20.2306. 0.2306. So does this look about 23% approximately? Yeah, it does to me. All right, let's take a look at the next page. A check for understanding. It says you run the university bookstore. Let X be the random variable that represents how many books per student the textbook company sells. So this is one book or two book or three books. Probability distribution is given on the formula table. Hey, most students are buying only one book. Because the random variable X has a mean of 1.5 and a standard deviation of 0.67. Oh, great. We don't have to calculate that. It's already given to us. Suppose that the revenue of the textbook company makes per student is 150 per book, and that each book has a fixed cost of $30. So we could say the profit is 150 minus 30. So therefore, the mean of y could be found by saying 150 times the mean of x minus 30, or 150 times 1.5 minus 30. That looks like 225 minus 30. That is 195, and that unit would be in dollars. What about standard deviation? Well, remember, only the multiplying part matters. So this would be 150 times 0.67. 150 times 0.67, and that's 100.5, and that is also in dollars. So there's the standard deviation of how much money is being made by that university bookstore. And we scroll down. Oh, there's our homework. That means we must be done with this part of the lecture.